This is a photograph of students at their outdoor college graduation ceremony. Figure 6. 1 investment choices. We generally view higher education as a good investment if one can afford it, regardless of the state of the economy. Credit. Modification of commencement by Rono College/Flickr. CC by 20. Chapter objectives. In this chapter, you will learn about consumption choices, how changes in income and prices affect consumption choices, how consumer choices might not always be rational. Bring it home. Making choices. The 2008-2009 Great Recession touched families around the globe. In too many countries, workers found themselves out of a job. In developed countries, unemployment compensation provided a safety net, but families still saw a marked decrease in disposable income and had to make tough spending decisions. Of course, non-essential, discretionary spending was the first to go. Even so, there was one particular category that saw a universal increase in spending worldwide during that time, an 18% uptick in the United States, specifically. You might guess that consumers began eating more meals at home, increasing grocery store spending. However, the Bureau of Labor Statistics Consumer Expenditure Survey, which tracks U.S. food spending over time, showed real total food spending by U.S. households declined 5% between 2006 and 2009. So, it was not groceries. What product would people around the world demand more of during tough economic times, and more importantly, why? Find out at chapter's end. That question leads us to this chapter's topic, analyzing how consumers make choices and how changes affect those choices. For instance, do changes in prices matter more or less than changes in a consumer's income? Can a small change in circumstances alter the consumer's perception of a product or even of their own resources? While many choices may seem straightforward, there is often much more to consider. Microeconomics seeks to understand the behavior of individual economic agents, such as individuals and businesses. Economists believe that we can analyze individuals' decisions, such as what goods and services to buy, as choices we make within certain budget constraints. Generally, consumers are trying to get the most for their limited budget. In economic terms, they are trying to maximize total utility or satisfaction given their budget constraint. Everyone has their own personal tastes and preferences. The French say, chacun a son goût, or each to his own taste. An old Latin saying states, de gustibus non est disputandum, or there's no disputing about taste. If people base their decisions on their own tastes and personal preferences, however, then how can economists hope to analyze the choices consumers make? An economic explanation for why people make different choices begins with accepting the proverbial wisdom that tastes are a matter of personal preference. However, economists also believe that the choices people make are influenced by their incomes, by the prices of goods and services they consume, and by factors like where they live. This chapter introduces the economic theory of how consumers make choices about what goods and services to buy with their limited income. The analysis in this chapter will build on the budget constraint that we introduced in the choice in a world of scarcity chapter. This chapter will also illustrate how economic theory provides a tool to systematically look at the full range of possible consumption choices, to predict how consumption responds to changes in prices or incomes. After reading this chapter, consult the appendix indifference curves to learn more about representing utility and choice through indifference curves. Learning objectives. By the end of this section, you will be able to calculate total utility, propose decisions that maximize utility, explain marginal utility, and the significance of diminishing marginal utility. Information on the consumption choices of Americans is available from the Consumer Expenditure Survey carried out by the U.S. Bureau of Labor Statistics. Table 6.1 shows spending patterns for the average U.S. household in 2010. The first row shows income and excluding taxes and personal savings. The second row shows that the average U.S. household spent $48,109 on consumption. The table then breaks down consumption into various categories. The average U.S. household spent roughly one-third of its consumption on shelter and other housing expenses, another one-third on food and vehicle expenses, and the rest on a variety of items, as shown. These patterns will vary for specific households by differing levels of family income, by geography, and by preferences. Average household income before taxes $62, $481. Average annual expenditures $48, $109. Food at home $3, $264. Food away from home $2, $505. Housing $16, $557. Apparel and services $1, $700. Transportation $7. 677, healthcare $3, $157. Entertainment $2, $504. Education $1, $74. Personal insurance and pensions $5, $357. All else. Alcohol, tobacco, reading, personal care, cash contributions. Miscellaneous $3,356. Table 6 U.S. consumption choices in 2010. Source: http://www.bls.gov/sex/CSZan13. PDF: Total utility and diminishing marginal utility. To understand how a household will make its choices, economists look at what consumers can afford, as shown in a budget constraint or budget line, and the total utility or satisfaction derived from those choices. In a budget constraint line, the quantity of one good is on the horizontal axis, and the quantity of the other good on the vertical axis. The budget constraint line shows the various combinations of two goods that are affordable given consumer income. Consider Jose's situation. Shown in Figure 6.2, Jose likes to collect t-shirts and watch movies. In Figure 6.2, we show the quantity of t-shirts on the horizontal axis, while we show the quantity of movies on the vertical axis. If Jose had unlimited income or goods were free, then he could consume without limit. However, Jose, like all of us, faces a budget constraint. Jose has a total of $56 to spend. The price of t-shirts is $14, and the price of movies is $7. Notice that the vertical intercept of the budget constraint line is at 8 movies and 0 t-shirts. 56/$7 equals 8. The horizontal intercept of the budget constraint is 4, where Jose spends of all of his money on t-shirts and no movies. 56/14 equals 4. The slope of the budget constraint line is rise-run, or 8/4 equals 2. The specific choices along the budget constraint line show the combinations of affordable t-shirts and movies. The points on the graph show how a budget is affected by spending choices. Spending more money at the movie's y-axis means that Jose has less money to spend on t-shirts x-axis. Figure 6.2, a choice between consumption goods. Jose has income of $56. Movies cost $7 and t-shirts cost $14. The points on the budget constraint line show the combinations of affordable movies and t-shirts. Jose wishes to choose the combination that will provide him with the greatest utility, which is the term economists use to describe a person's level of satisfaction or happiness with their choices. Let's begin with an assumption, which we will discuss in more detail later, that Jose can measure his own utility with something called utils. It is important to note that you cannot make comparisons between the utils of individuals. If one person gets 20 utils from a cup of coffee and another gets 10 utils, this does not mean that the first person gets more enjoyment from the coffee than the other, or that they enjoy the coffee twice as much. The reason why is that utils are subjective to an individual. The way one person measures utils is not the same as the way someone else does. Table 6.2 shows how Jose's utility is connected with his t-shirt or movie consumption. The first column of the table shows the quantity of t-shirts consumed. The second column shows the total utility, or total amount of satisfaction, that Jose receives from consuming that number of t-shirts. The most common pattern of total utility in this example is that consuming additional goods leads to greater total utility, but at a decreasing rate. The third column shows marginal utility, which is the additional utility provided by one additional unit of consumption. This equation for marginal utility is mu equals change in total utility change in quantity. Notice that marginal utility diminishes as additional units are consumed, which means that each subsequent unit of a good consumed provides less additional utility. For example, the first t-shirt Jose picks is his favorite, and it gives him an addition of 22 utils. The fourth t-shirt is just something to wear when all his other clothes are in the wash and yields only 18 additional utils. This is an example of the law of diminishing marginal utility, which holds that the additional utility decreases with each unit added. Diminishing marginal utility is another example of the more general law of diminishing returns we learned earlier in the chapter on choice in a world of scarcity. The rest of Table 6.2 shows the quantity of movies that Jose attends, and his total and marginal utility from seeing each movie. Total utility follows the expected pattern. It increases as the number of movies that Jose watches rises. Marginal utility also follows the expected pattern. Each additional movie brings a smaller gain in utility than the previous one. The first movie Jose attends is the one he wanted to see the most, and thus provides him with the highest level of utility or satisfaction. The fifth movie he attends is just to kill time. Notice that total utility is also the sum of the marginal utilities. Read the next work it out feature for instructions on how to calculate total utility. T-shirts quantity. Total utility marginal utility movies. Quantity. Total utility marginal utility 122.22, 116.16, 243.21, 230, 115, 363, 23, 45, 14, 481, 18, 458, 13, 597, 16, 570, 12, 6, 111, 14, 6, 81, 11, 7, 123, 12, 7, 91, 10, 8, 133, 10, 8, 109. Table 6. 2. Total and marginal utility. Table 6.3 looks at each point on the budget constraint in Figure 6.2 and adds up Jose's total utility for 5 possible combinations of t-shirts and movies. Point t-shirts movies total utility P4081 plus 0 equals 80, 1Q3263 plus 31 equals 94 R2 443 plus 58 equals 101 S 1622 plus 81 equals 103 T080 plus 100 equals 100. Table 6. 3. Finding the choice with the highest utility. Work it out calculating total utility. Let's look at how Jose makes his decision in more detail. Step 1. Observe that, at point Q, for example, Jose consumes 3 t-shirts and 2 movies. Step 2. Look at Table 6.2. You can see from the 4th row second column that 3 t-shirts are worth 63 utils. Similarly, the second row 5th column shows that 2 movies are worth 31 utils. Step 3. From this information, you can calculate that point Q has a total utility of 94, 63 plus 31. Step 4. You can repeat the same calculations for each point on Table 6. 3, in which the total utility numbers are shown in the last column. For Jose, the highest total utility for all possible combinations of goods occurs at point S, with a total utility of 103 from consuming 1 t-shirt and 6 movies. Choosing with marginal utility, most people approach their utility-maximizing combination of choices in a step-by-step way. This approach is based on looking at the trade-offs, measured in terms of marginal utility, of consuming less of one good and more of another. For example, say that Jose starts off thinking about spending all his money on t-shirts and choosing point P, which corresponds to 4 t-shirts and no movies, as figure 6.2 illustrates. Jose chooses this starting point randomly as he has to start somewhere. Then he considers giving up the last t-shirt, the one that provides him the least marginal utility, and using the money he saves to buy 2 movies instead. Table 6.4 tracks the step-by-step series of decisions Jose needs to make. Key T-shirts are $14, movies are $7, and income is $56. The following Work It Out feature explains how marginal utility can affect decision-making. Try, which has total utility, marginal gain, and loss of utility, compared with previous choice. Conclusion. Choice 1. P4 t-shirts and 0 movies. 81 from 4 t-shirts plus 0 from 0 movies equals 81. Choice 2. Q3 t-shirts and 2 movies. 63 from 3 t-shirts plus 31 from 0 movies equals 94. Loss of 18 from 1 less t-shirt, but gain of 31 from 2 more movies. For a net utility gain of 13, Q is preferred over P. Choice 3. Are 2 t-shirts and 4 movies. 43 from 2 t-shirts plus 58 from 4 movies equals 101. Loss of 20 from 1 less t-shirt, but gain of 27 from 2 more movies. For a net utility gain of 7, R is preferred over Q. Choice 4. S1 t-shirt and 6 movies. 22 from 1 t-shirt plus 81 from 6 movies equals 103. Loss of 21 from 1 less t-shirt, but gain of 23 from 2 more movies. For a net utility gain of 2, S is preferred over R. Choice 5. T0 t-shirts and 8 movies. 0 from 0 t-shirts plus 100 from 8 movies equals 100. Loss of 22 from 1 less t-shirt, but gain of 19 from 2 more movies. For a net utility loss of 3, S is preferred over T. Table 6. For a step-by-step approach to maximizing utility work, it out decision-making by comparing marginal utility. Jose could use the following thought process, if he thought in utils, to make his decision regarding how many t-shirts and movies to purchase. Step 1. From Table 6.2, Jose can see that the marginal utility of the 4th t-shirt is 18. If Jose gives up the 4th t-shirt, then he loses 18 utils. Step 2. Giving up the 4th t-shirt, however, frees up $14, the price of a t-shirt, allowing Jose to buy the first 2 movies at $7 each. Step 3. Jose knows that the marginal utility of the first movie is 16, and the marginal utility of the second movie is 15. Thus, if Jose moves from point P to point Q, he gives up 18 utils from the t-shirt, but gains 31 utils from the movies. Step 4. Gaining 31 utils and losing 18 utils is a net gain of 13. This is just another way of saying that the total utility at Q, 94, according to the last column in Table 6. 3 is 13 more than the total utility at P, 81. Step 5. Thus, for Jose, it makes sense to give up the 4th t-shirt in order to buy 2 movies. Jose clearly prefers point Q to point P. Now repeat this step-by-step process of decision-making with marginal utilities. Jose thinks about giving up the 3rd t-shirt and surrendering a marginal utility of 20 in exchange for purchasing 2 more movies that promise a combined marginal utility of 27. Jose prefers point R to point Q. What if Jose thinks about going beyond R to point S? Giving up the 2nd t-shirt means a marginal utility loss of 21, and the marginal utility gain from the 5th and 6th movies would combine to make a marginal utility gain of 23, so Jose prefers point S to R. However, if Jose seeks to go beyond point S to point T, he finds that the loss of marginal utility from giving up the first t-shirt is 22, while the marginal utility gained from the last 2 movies is only a total of 19. If Jose were to choose point T, his utility would fall to 100. Through these stages of thinking about marginal trade-offs, Jose again concludes that S, with 1 t-shirt and 6 movies, is the choice that will provide him with the highest level of total utility. This step-by-step approach will reach the same conclusion regardless of Jose's starting point. We can develop a more systematic way of using this approach by focusing on satisfaction per dollar. If an item costing $5 yields 10 utils, then it's worth 2 utils per dollar spent. Marginal utility per dollar is the amount of additional utility Jose receives divided by the product's price. Table 6. 5 shows the marginal utility per dollar for Jose's t-shirts and movies. Marginal utility per dollar equals marginal utility price if Jose wants to maximize the utility he gets from his limited budget. He will always purchase the item with the greatest marginal utility per dollar of expenditure, assuming he can afford it with his remaining budget. Jose starts with no purchases. If he purchases a t-shirt, the marginal utility per dollar spent will be 1.6. If he purchases a movie, the marginal utility per dollar spent will be 2.3. Therefore, Jose's first purchase will be the movie. Why? Because it gives him the highest marginal utility per dollar and is affordable. Next, Jose will purchase another movie. Why? Because the marginal utility of the next movie, 2.14, is greater than the marginal utility of the next t-shirt, 1.6. Note that when Jose has no t-shirts, the next one is the first one. Jose will continue to purchase the next good with the highest marginal utility per dollar until he exhausts his budget. He will continue purchasing movies because they give him a greater bang for the buck until the sixth movie, which gives the same marginal utility per dollar as the first t-shirt purchase. Jose has just enough budget to purchase both. So in total, Jose will purchase 6 movies and 1 t-shirt. Quantity of t-shirts, total utility, marginal utility per dollar. Quantity of movies, total utility per dollar. 1.22, 22 slash $14 equals 1. 6 116 16 16 slash $7 equals 2. 3 2 43 21 21 slash $14 equals 1. 5 2 31 15 15 slash $7 equals 2. 14 3 63 20 slash $14 equals 1. 4 3 45 14 14 slash $7 equals 2. 4 81 18 18 slash $14 equals 1. 3 4 58 13 13 slash $7 equals 1. 9 5 97 16 16 slash $14 equals 1. 1 5 70 12 12 slash $7 equals 1. 7 6 111 14 14 slash $14 equals 1. 6 80 1 11 11 slash $7 equals 1. 6 7 123 12 12 slash $14 equals 1. 2 7 91 10 10 slash $7 equals 1. 4 Table 6. 5 Marginal utility per dollar. A rule for maximizing utility. This process of decision-making suggests a rule to follow when maximizing utility. Since the price of t-shirts is twice as high as the price of movies, to maximize utility, the last t-shirt that Jose chose needs to provide exactly twice the marginal utility, mu, of the last movie. If the last t-shirt provides less than twice the marginal utility of the last movie, then the t-shirt is providing less bang for the buck, i.e., marginal utility per dollar spent, than Jose would receive from spending the same money on movies. If this is so, Jose should trade the t-shirt for more movies to increase his total utility. If the last t-shirt provides more than twice the marginal utility of the last movie, then the t-shirt is providing more bang for the buck, or marginal utility per dollar, than if the money were spent on movies. As a result, Jose should buy more t-shirts. Notice that at Jose's optimal choice of point S, the marginal utility from the first t-shirt of 22 is exactly twice the marginal utility of the sixth movie, which is 11. At this choice, the marginal utility per dollar is the same for both goods. This is a telltale signal that Jose has found the point with highest total utility. We can write this argument as a general rule. If you always choose the item with the greatest marginal utility per dollar spent, when your budget is exhausted, the utility maximizing choice should occur where the marginal utility per dollar spent is the same for both goods. Mu1P1 equals Mu2P2. A sensible economizer will pay twice as much for something only if, in the marginal comparison, the item confers twice as much utility. Notice that the formula for the table above is $22.141. 6 equals $11.71. 6. The following Work It Out feature provides step-by-step guidance for this concept of utility maximizing choices. Work it out maximizing utility. The general rule, Mu1P1 equals Mu2P2, means that the last dollar spent on each good provides exactly the same marginal utility. This is the case at point S. So, Step 1. If we traded $1 more of movies for $1 more of t-shirts, the marginal utility gained from t-shirts would exactly offset the marginal utility lost from fewer movies. In other words, the net gain would be zero. Step 2. Products, however, usually cost more than $1, so we cannot trade $1's worth of movies. The best we can do is trade 2 movies for another t-shirt, since in this example t-shirts cost twice what a movie does. Step 3. If we trade 2 movies for 1 t-shirt, we would end up at point R 2 t-shirts and 4 movies. Step 4. Choice 4 in Table 6.4 shows that if we move to point R, we would gain 21 utils from 1 more t-shirt, but lose 23 utils from 2 fewer movies, so we would end up with less total utility at point R. In short, the general rule shows us the utility maximizing choice, which is called the consumer equilibrium. There is another equivalent way to think about this. We can also express the general rule as the ratio of the prices of the 2 goods should be equal to the ratio of the marginal utilities. When we divide the price of good 1 by the price of good 2, at the utility maximizing point, this will equal the marginal utility of good 1 divided by the marginal utility of good 2. P1 P2 equals Mu1 Mu2 along the budget constraint. The total price of the 2 goods remains the same, so the ratio of the prices does not change. However, the marginal utility of the 2 goods changes with the quantities consumed. At the optimal choice of 1 t-shirt and 6 movies, point S, the ratio of marginal utility to price for t-shirts, 22:14, matches the ratio of marginal utility to price for movies, of 11:7. Measuring utility with numbers. This discussion of utility began with an assumption that it is possible to place numerical values on utility, an assumption that may seem questionable. You can buy a thermometer for measuring temperature at the hardware store, but what store sells a utilometer for measuring utility? While measuring utility with numbers is a convenient assumption to clarify the explanation, the key assumption is not that an outside party can measure utility, but only that individuals can decide which of 2 alternatives they prefer. To understand this point, think back to the step-by-step process of finding the choice with highest total utility by comparing the marginal utility you gain and lose from different choices along the budget constraint. As Jose compares each choice along his budget constraint to the previous choice, what matters is not the specific numbers that he places on his utility, or whether he uses any numbers at all, but only that he personally can identify which choices he prefers. In this way, the step-by-step process of choosing the highest level of utility resembles rather closely how many people make consumption decisions. We think about what will make us the happiest. We think about what things cost. We think about buying a little more of one item and giving up a little of something else. We choose what provides us with the greatest level of satisfaction. The vocabulary of comparing the points along a budget constraint and total and marginal utility is just a set of tools for discussing this everyday process in a clear and specific manner. It is welcome news that specific utility numbers are not central to the argument, since a good utilometer is hard to find. Do not worry. While we cannot measure utils by the end of the next module, we will have transformed our analysis into something we can measure: demand. Learning objectives. By the end of this section, you will be able to explain how income, prices, and preferences affect consumer choices, contrast the substitution effect and the income effect, utilize concepts of demand to analyze consumer choices, apply utility maximizing choices to governments and businesses, just as we can use utility and marginal utility to discuss making consumer choices along a budget constraint. We can also use these ideas to think about how consumer choices change when the budget constraint shifts in response to changes in income or price. Because we can use the budget constraint framework to analyze how quantities demanded change because of price movements, the budget constraint model can illustrate the underlying logic behind demand curves, how changes in income affect consumer choices. Let's begin with a concrete example illustrating how changes in income level affect consumer choices. Figure 6.3 shows a budget constraint that represents Kimberly's choice between concert tickets at $50 each and getting away overnight to a bed and breakfast for $200 per night. Kimberly has $1,000 per year to spend between these two choices. After thinking about her total utility and marginal utility, and applying the decision rule that the ratio of the marginal utilities to the prices should be equal between the two products, Kimberly chooses point M, with 8 concerts and 3 overnight getaways as her utility maximizing choice. The graph's various points represent which good is viewed as inferior. The first solid downward sloping line represents the original budget constraint. The second budget constraint represents a different set of options based on the consumer having more money to spend on both items. Figure 6.3 how a change in income affects consumption choices. The utility maximizing choice on the original budget constraint is M. The dashed horizontal and vertical lines extending through point M allow you to see at a glance whether the quantity consumed of goods on the new budget constraint is higher or lower than on the original budget constraint. On the new budget constraint, Kimberly will make a choice like N if both goods are normal goods. If overnight stays is an inferior good, Kimberly will make a choice like P. If concert tickets are an inferior good, Kimberly will make a choice like Q. Now, assume that the income Kimberly has to spend on these two items rises to $2,000 per year, causing her budget constraint to shift out to the right. How does this rise in income alter her utility maximizing choice? Kimberly will again consider the utility and marginal utility that she receives from concert tickets and overnight getaways and seek her utility maximizing choice on the new budget line. But how will her new choice relate to her original choice? We can replace the possible choices along the new budget constraint into 3 groups, which the dashed horizontal and vertical lines that pass through the original choice M in the figure divide. All choices on the upper left of the new budget constraint that are to the left of the vertical dashed line, like choice P with 2 overnight stays and 32 concert tickets, involve less of the good on the horizontal axis, but much more of the good on the vertical axis. All choices to the right of the vertical dashed line and above the horizontal dashed line, like choice N with 5 overnight getaways and 20 concert tickets, have more consumption of both goods. Finally, all choices that are to the right of the vertical dashed line, but below the horizontal dashed line, like choice Q with 4 concerts and 9 overnight getaways, involve less of the good on the vertical axis, but much more of the good on the horizontal axis. All of these choices are theoretically possible, depending on Kimberly's personal preferences as expressed through the total and marginal utility she would receive from consuming these two goods. When income rises, the most common reaction is to purchase more of both goods, like choice N, which is to the upper right relative to Kimberly's original choice M, although exactly how much more of each good will vary according to personal taste. Conversely, when income falls, the most typical reaction is to purchase less of both goods. As we defined in the chapter on demand and supply and again in the chapter on elasticity, we call goods and services normal goods when a rise in income leads to a rise in the quantity consumed of that good, and a fall in income leads to a fall in quantity consumed. However, depending on Kimberly's preferences, a rise in income could cause consumption of one good to increase while consumption of the other good declines. A choice like P means that a rise in income caused her quantity consumed of overnight stays to decline, while a choice like Q would mean that a rise in income caused her quantity of concerts to decline. Goods where demand declines as income rises, or conversely, where the demand rises as income falls, are called inferior goods. An inferior good occurs when people trim back on a good as income rises, because they can now afford the more expensive choices that they prefer. For example, a higher income household might eat fewer hamburgers or be less likely to buy a used car, and instead eat more steak and buy a new car. How price changes affect consumer choices. For analyzing the possible effect of a change in price on consumption, let's again use a concrete example. Figure 6.4 represents Sergey's consumer choice, who chooses between purchasing baseball bats and cameras. A price increase for baseball bats would have no effect on the ability to purchase cameras, but it would reduce the number of bats Sergey could afford to buy. Thus, a price increase for baseball bats, the good on the horizontal axis, causes the budget constraint to rotate inward, as if on a hinge, from the vertical axis. As in the previous section, the point labeled M represents the originally preferred point on the original budget constraint, which Sergey has chosen after contemplating his total utility and marginal utility, and the trade-offs involved along the budget constraint. In this example, the units along the horizontal and vertical axes are not numbered, so the discussion must focus on whether Sergey will consume more or less of certain goods, not on numerical amounts. This graph illustrates a budget constraint. The spending choices are between cameras, shown on the y-axis, and baseball bats, shown on the x-axis. The budget constraint is a downward-sloping line. In this example, the price of baseball bats has increased, and the budget constraint is shown shifting in. The original utility maximizing choice is point M on the original budget constraint, and the new budget constraint shows 4 different consumption possibilities, points H, J, K, and L. Figure 6. For how a change in price affects consumption choices, the original utility maximizing choice is M when the price rises. The budget constraint rotates clockwise. The dashed lines make it possible to see at a glance whether the new consumption choice involves less of both goods, or less of one good and more of the other. The new possible choices would be fewer baseball bats and more cameras, like point H, or less of both goods, as at point J. Choice K would mean that the higher price of bats led to exactly the same quantity of bat consumption, but fewer cameras. Theoretically possible, but unlikely in the real world, we rule out choices like L because they would mean that a higher price for baseball bats means a greater consumption of baseball bats. After the price increase, Sergey will make a choice along the new budget constraint. Again, we can divide his choices into 3 segments by the dashed vertical and horizontal lines. In the upper left portion of the new budget constraint, at a choice like H, Sergey consumes more cameras and fewer bats. In the central portion of the new budget constraint, at a choice like J, he consumes less of both goods. At the right-hand end, at a choice like L, he consumes more bats but fewer cameras. The typical response to higher prices is that a person chooses to consume less of the product with the higher price. This occurs for 2 reasons, and both effects can occur simultaneously. The substitution effect occurs when a price changes and consumers have an incentive to consume less of the good with a relatively higher price and more of the good with a relatively lower price. The income effect is that a higher price means, in effect, the buying power of income has been reduced even though actual income has not changed, which leads to buying less of the good, when the good is normal. In this example, the higher price for baseball bats would cause Sergey to buy fewer bats for both reasons. Exactly how much will a higher price for bats cause Sergey's bat consumption to fall? Figure 6.4 suggests a range of possibilities. Sergey might react to a higher price for baseball bats by purchasing the same quantity of bats, but cutting his camera consumption. This choice is the point K on the new budget constraint, straight below the original choice M. Alternatively, Sergey might react by dramatically reducing his bat purchases and instead buy more cameras. The key is that it would be imprudent to assume that a change in the price of one good will only affect consumption of that good. In our example, since Sergey purchases all his products out of the same budget, a change in the price of baseball bats can also have a range of effects, either positive or negative, on his purchases of cameras. Since Sergey purchases all his products out of the same budget, a change in the price of baseball bats can also have a range of effects, either positive or negative, on his purchases of cameras. In short, a higher price typically causes reduced consumption of the good in question, but it can affect the consumption of other goods as well. Link it up. Read this article about the potential of variable prices in vending machines. The foundations of demand curves. Changes in the price of a good lead the budget constraint to rotate. A rotation in the budget constraint means that when individuals are seeking their highest utility, the quantity that is demanded of that good will change. In this way, the logical foundations of demand curves, which show a connection between prices and quantity demanded, are based on the underlying idea of individuals seeking utility. Figure 6.5 shows a budget constraint with a choice between housing and everything else. Putting everything else on the vertical axis can be a useful approach in some cases, especially when the focus of the analysis is on one particular good. We label the preferred choice on the original budget constraint that provides the highest possible utility M0. The other three budget constraints represent successively higher prices for housing of P1, P2, and P3. As the budget constraint rotates in and in again, we label the utility maximizing choices M1, M2, and M3, and the quantity demanded of housing falls from Q0 to Q1 to Q2 to Q3. The two graphs show how budget constraints influence the demand curve. Figure 6.5, the foundations of a demand curve. An example of housing, A. As the price increases from P0 to P1 to P2 to P3, the budget constraint on the upper part of the diagram rotates clockwise. The utility maximizing choice changes from M0 to M1 to M2 to M3. As a result, the quantity demanded of housing shifts from Q0 to Q1 to Q2 to Q3, ceteris paribus. B. The demand curve graphs each combination of the price of housing and the quantity of housing demanded, ceteris paribus. The quantities of housing are the same at the points on both A and B. Thus, the original price of housing P0 and the original quantity of housing Q0 appear on the demand curve as point E0. The higher price of housing P1 and the corresponding lower quantity demanded of housing Q1 appear on the demand curve as point E1. Thus, as the price of housing rises, the budget constraint rotates clockwise and the quantity consumed of housing falls, ceteris paribus meaning, with all other things being the same. We graph this relationship, the price of housing rising from P0 to P1 to P2 to P3, while the quantity of housing demanded falls from Q0 to Q1 to Q2 to Q3. On the demand curve in Figure 6.5b, the vertical dashed lines stretching between the top and bottom of Figure 6.5 show that the quantity of housing demanded at each point is the same in both A and B. We ultimately determine the shape of a demand curve by the underlying choices about maximizing utility subject to a budget constraint. While economists may not be able to measure utils, they can certainly measure price and quantity demanded. Applications in government and business. The budget constraint framework for making utility maximizing choices offers a reminder that people can react to a change in price or income in a range of different ways. For example, in the winter months of 2005, costs for heating homes increased significantly in many parts of the country as prices for natural gas and electricity soared, due in large part to the disruption caused by Hurricanes Katrina and Rita. Some people reacted by reducing the quantity demanded of energy. For example, by turning down the thermostats in their homes by a few degrees and wearing a heavier sweater inside. Even so, many home heating bills rose, so people adjusted their consumption in other ways too. As you learned in the chapter on elasticity, the short-run demand for home heating is generally inelastic. Each household cut back on what it valued least on the margin. For some, it might have been some dinners out, or a vacation, or postponing buying a new refrigerator or a new car. Sharply higher energy prices can have effects beyond the energy market, leading to a widespread reduction in purchasing throughout the rest of the economy. A similar issue arises when the government imposes taxes on certain products, such as on gasoline, cigarettes, and alcohol. Say that a tax on alcohol leads to a higher price at the liquor store. The higher price of alcohol causes the budget constraint to pivot left, and alcoholic beverage consumption is likely to decrease. However, people may also react to the higher price of alcoholic beverages by cutting back on other purchases. For example, they might cut back on snacks at restaurants like chicken wings and nachos. It would be unwise to assume that the liquor industry is the only one affected by the tax on alcoholic beverages. Read the next Clear It Up to learn about how who controls the household income influences buying decisions. The unifying power of the utility maximizing budget set framework. An interaction between prices, budget constraints, and personal preferences determine household choices. The flexible and powerful terminology of utility maximizing gives economists a vocabulary for bringing these elements together. Not even economists believe that people walk around mumbling about their marginal utilities before they walk into a shopping mall, accept a job, or make a deposit in a savings account. However, economists do believe that individuals seek their own satisfaction or utility, and that people often decide to try a little less of one thing and a little more of another. If we accept these assumptions, then the idea of utility maximizing households facing budget constraints becomes highly plausible. Clear it up. Does who controls household income make a difference? In the mid-1970s, the United Kingdom made an interesting policy change in its child allowance policy. This program provides a fixed amount of money per child to every family, regardless of family income. Traditionally, the child allowance had been distributed to families by withholding less in taxes from the paycheck of the family wage earner, typically the father in this time period. The new policy instead provided the child allowance as a cash payment to the mother. As a result of this change, households have the same level of income and face the same prices in the market, but the money is more likely to be in the mother's purse than in the father's wallet. Should this change in policy alter household consumption patterns? Basic models of consumption decisions, of the sort that we examined in this chapter, assume that it does not matter which parent or guardian receives the money, because both seek to maximize the family's utility as a whole. In effect, this model assumes that everyone in the family has the same makeup or has the same preferences. There has not been extensive research on diverse family structures and guardian parent sex and gender related to spending. However, the older research on families with one man and one woman parent indicates that gender does affect spending decisions. When the mother controls a larger share of family income, a number of studies, in the United Kingdom and in a wide variety of other countries, have found that the family tends to spend more on restaurant meals, child care, and women's clothing, and less on alcohol and tobacco. As the mother controls a larger share of household resources, children's health improves too. These findings suggest that when providing assistance to families, in high-income countries and low-income countries alike, the monetary amount of assistance is not all that matters. It also matters which family member actually receives the money. The budget constraint framework serves as a constant reminder to think about the full range of effects that can arise from changes in income or price, not just effects on the one product that might seem most immediately affected. Learning objectives. By the end of this section, you will be able to evaluate the reasons for making intertemporal choices, interpret an intertemporal budget constraint, analyze why people in America tend to save such a small percentage of their income. As we know, people sometimes make decisions that seem irrational and not in their own best interest. People's decisions can seem inconsistent from one day to the next, and they even deliberately ignore ways to save money or time. The traditional economic models assume rationality, which means that people take all available information and make consistent and informed decisions that are in their best interest. In fact, economics professors often delight in pointing out so-called irrational behavior each semester to their new students, and present economics as a way to become more rational. However, a new group of economists, known as behavioral economists, argue that the traditional method omits something important: people's state of mind. For example, one can think differently about money if one is feeling revenge, optimism, or loss. These are not necessarily irrational states of mind, but part of a range of emotions that can affect anyone on a given day. In addition, actions under these conditions are predictable if one better understands the underlying environment. Behavioral economics seeks to enrich our understanding of decision-making by integrating the insights of psychology into economics. It does this by investigating how given dollar amounts can mean different things to individuals depending on the situation. This can lead to decisions that appear outwardly inconsistent or irrational to the outside observer. The way the mind works, according to this view, may seem inconsistent to traditional economists, but is actually far more complex than an unemotional cost-benefit adding machine. For example, a traditional economist would say that if you lost a $10 bill today and also received an extra $10 in your paycheck, you should feel perfectly neutral. After all, $10 plus $10 equals $0. You are the same financially as you were before. However, behavioral economists have conducted research that shows many people will feel some negative emotion, such as anger or frustration, after those two things happen. We tend to focus more on the loss than the gain. We call this loss aversion, where a $1 loss pains us 25 times more than a $1 gain helps us, according to the economists Daniel Kahneman and Amos Tversky in a famous 1979 article in the journal Econometrica. This insight has implications for investing, as people tend to overplay the stock market by reacting more to losses than to gains. This behavior looks irrational to traditional economists, but is consistent once we understand better how the mind works, these economists argue. Traditional economists also assume human beings have complete self-control. But for instance, people will buy cigarettes by the pack instead of the carton, even though the carton saves them money, to keep usage down. They purchase locks for their refrigerators and overpay on taxes to force themselves to save. In other words, we protect ourselves from our worst temptations but pay a price to do so. One way behavioral economists are responding to this is by establishing ways for people to keep themselves free of these temptations. This includes what we call nudges toward more rational behavior rather than mandatory regulations from government. For example, up to 20% of new employees do not enroll in retirement savings plans immediately because of procrastination or feeling overwhelmed by the different choices. Some companies are now moving to a new system where employees are automatically enrolled unless they opt out. Almost no one opts out in this program, and employees begin saving at the early years, which are most critical for retirement. Another area that seems illogical is the idea of mental accounting, or putting dollars in different mental categories where they take different values. Economists typically consider dollars to be fungible, or having equal value to the individual, regardless of the situation. You might, for instance, think of the $25 you found in the street differently from the $25 you earned from 3 hours working in a fast food restaurant. You might treat the street money as mad money, with little rational regard to getting the best value. This is in one sense strange, since it is still equivalent to 3 hours of hard work in the restaurant. Yet the easy come easy go mentality replaces the rational economizer because of the situation, or context, in which you attain the money. In another example of mental accounting that seems inconsistent to a traditional economist, a person could carry a credit card debt of $1,000 that has a 15% yearly interest cost, and simultaneously have a $2,000 savings account that pays only 2% per year. That means she pays $150 a year to the credit card company, while collecting only $40 annually in bank interest, so she loses $110 a year. That doesn't seem wise. The rational decision would be to pay off the debt, since a $1,000 savings account with $0 in debt is the equivalent net worth, and she would now net $20 per year. Curiously, it is not uncommon for people to ignore this advice, since they will treat a loss to their savings account as higher than the benefit of paying off their credit card. They do not treat the dollars as fungible, so it looks irrational to traditional economists. Which view is right, the behavioral economists or the traditional view? Both have their advantages, but behavioral economists have at least identified trying to describe and explain behavior that economists have historically dismissed as irrational. If most of us are engaged in some irrational behavior, perhaps there are deeper underlying reasons for this behavior in the first place. Bring it home. Making choices. In what category did consumers worldwide increase their spending during the Great Recession? Higher education. According to the United Nations Educational, Scientific, and Cultural Organization, UNESCO, enrollment in colleges and universities rose 1/3 in China and almost 2/3 in Saudi Arabia, nearly doubled in Pakistan, tripled in Uganda, and surged by 3 million, 18% in the United States. Why were consumers willing to spend on education during lean times? Both individuals and countries view higher education as the way to prosperity. Many feel that increased earnings are a significant benefit of attending college. U.S. Bureau of Labor Statistics data from May 2012 supports this view, as Figure 6.6 shows. They show a positive correlation between earnings and education. The data also indicate that unemployment rates fall with higher levels of education and training. Why spend the money to go to college during recession? Because if you are unemployed or underemployed, working fewer hours than you would like, the opportunity cost of your time is low. If you're unemployed, you don't have to give up work hours and income by going to college. The graph shows the unemployment rate and median weekly earnings in 2012 for various levels of education. People with professional degrees made around $1,735 a week and suffered a 2.1% unemployment rate. People with doctoral degrees made around $1,624 a week and suffered a 2.5% unemployment rate. People with master's degrees made around $1,300 a week and suffered a 3.5% unemployment rate. People with bachelor's degrees made around $1,066 a week and suffered a 4.5% unemployment rate. People with associate's degrees made around $785 a week and suffered a 6.2% unemployment rate. People with some college, no degree made around $727 a week and suffered a 7.7% unemployment rate. People with a high school diploma made around $652 a week and suffered an 8.3% unemployment rate. People with less than a high school diploma made around $471 a week and suffered a 12.4% unemployment rate. Figure 6.6. The impact of education on earnings and unemployment rates. 2012. Those with the highest degrees in 2012 had substantially lower unemployment rates, whereas those with the least formal education suffered from the highest unemployment rates. The national median average weekly income was $815, and the nation unemployment average in 2012 was 6.8%. Source: U.S. Bureau of Labor Statistics, May 22, 2013.